All right, I wanted to make sure that I took a look at the AP Physics exam practice exam 3. There's going to be a little of what I would call a bonus question if this popped up on a real exam here. So we have two blocks, and we want to begin first by drawing the free body diagram. And of course, we always ask if there's friction. So for the block, there's a normal on block B due to the slab. There's the weight of block B due to the earth. And there is a friction force on block B due to the slab. Now for the slab, there is a normal on the slab due to the earth. And let's be careful, we have Newton's third law here. We have the friction on the slab due to the block. So here's one third law pair. We have a second third law pair. We have a normal on the slab due to the block by Newton's third law. And we have the weight of the slab due to the earth. And then we're told at some moment later the block reaches the right end of the slab. Both the block and the slab attain identical speeds, and we want to calculate VF. So for part B, what we're going to do is we're going to actually get the equation of motion for each block. So we're going to have here for the block V equals A of the block times T plus V naught. And for the slab, we're going to get a similar equation. V is A of the slab times T plus V naught. And I'll say of the slab and of the block. Now let's look at the forces on the block. Well, there's the kinetic friction on the block from the slab, so I'll just call that mu. I guess we could call it kinetic, but there's only one to worry about. And so we're going to end up getting that the friction on the block due to the slab is going to end up being mu times mass of the block times g. So that's the force on it. And this is a force that slows it down. It's pointing to the left. So what this tells us is if we're looking at this block slowing down, we have the mass of the block times its acceleration is negative mu mass of the block times g. The masses cancel, and so the acceleration of the block is negative mu times g. So we have v of the block is negative mu times g times t plus its v naught, which is going to be 4 meters per second, but we'll put that in a second. Now for the slab, similarly, by Newton's third law, we have that negative mu mass of the block times g. That's the friction force. That makes the big slab accelerate. And so we end up getting mu mb times g over mass of the slab is the acceleration of the slab. And its initial speed is 0. So v of the slab is going to equal mu mass of the block over the mass of the slab times t. So let's get that final speed, or that they have the same speed, and let's solve for that same speed that they end up getting. So we can actually say that, and this should be a g here, sorry about that. So I'm going to actually put in the numbers. I could do it with letters, but it's a little bit easier with numbers. So VB, so that's negative 0.2 times 10, so that's V is negative 2t plus 4 for the block. And for the slab, it's going to be here, 0.2 times 10 is 2, And then block over slab is going to be 0.5 over 6. So that's going to be 1 over 6. So that's going to end up being 0.33 times t for the slab when we put in our numbers. Now we can set these equal to get the time. So we get negative 2t plus 4 is 0.33. We get 2.33 times t equals 4. T ends up being, 4 divided by 2. Yeah, so about 1.72 seconds. And when we actually solve for that speed, we end up getting about 0.57 seconds. Now, the distance traveled by the slab, the moment it reaches VF, well, we can actually say that the distance is going to end up being 1/2 a of the slab times t squared. And that's going to be x of the slab is 1/2. The acceleration is 0.33 times t squared. And the t we got was 1.7. So when we get x of the slab, that's going to be we're going to end up getting about 0.48 meters. Now for part D, we would actually do that in the next unit, but I would do work as the change in kinetic energy, which is 1/2 mv final squared, but that's not on the test. So that is free response question number 1 on the third practice test.